adding all these products. All right, so let's do an example. Let's say we're talking about puppies. We did an experiment and with a bunch of mama dogs or whatever, and we found that they either had 2 puppies, 3 puppies, 4 puppies, or 6 puppies. For some reason they couldn't have 5. And we did 25 experiments, let's say. And we found that 4 of the mama dogs had 2 puppies. 10 had 3 puppies. 8 had 4 puppies. And 3 had 6 puppies. So if we added all those up, they do add up to 1. Now we want to find the expected value. So I did this experiment with 25 dogs, mama dogs. I want to know what is the expected value of how many puppies a dog will have. So the question is expected value of puppies. So some could have 2, some could have 6. I want to find the average. So what you have to do is you have to multiply the outcomes times the probability. We'll call that the product column. So we're going to multiply the outcome. So this is the outcome category. The outcomes were either 2, 3, 4, or 6. We're going to multiply the outcomes times the probability. So 2 times this fraction. Now that might seem hard to do, but really all you have to do is multiply this number times the top number. So I don't even really need a calculator, I don't think. So 2 times 4 is 8. And the bottom stays the same. 3 times 10 is 30. And the bottom stays the same. Now, if you want, you can make those decimals. I could have multiplied, so I could have gone 3 times 10 divided by 25 and write 1.2. So you can make those decimals if you want. So if it is hard to multiply the top numbers, you could just use a calculator. 4 times 8 is 32. And again, we could use a calculator if we wanted to. 6 times 3 is 18. Then what we want to do is add all these numbers together. All right. Now again, you don't have to use a calculator, but adding up fractions, you know the bottom's going to stay the same. So all I have to do is add the top numbers. 8 plus 30 plus 32 plus 18. So the top number is 88. Now, you can keep your answer like this, but if someone asked you how many on average, how many puppies would you have on average, usually you don't give an answer as a fraction. So I'll just change this to a decimal. It doesn't have to be done, but 88 divided by 25 is 3.52. So what that means is, on average, mama dog will have 3.5 babies. So that's an average. Obviously, you can't have half a baby, but an average can be a decimal. Now, another way of thinking of this, like what I like to compare it to, is like a casino. The number one job of a casino is to make money. All right. So, but they want to make the game appealing so people will play it. But the odds are always in their favor. So let's just pretend this was a casino game. And every time you played this game, you're either going to win $2, $3, $4, or $6. So maybe it's like a circle, spin the wheel thing, and they got all these numbers, and obviously there isn't as many sixes written down. So it's spinning the wheel like Wheel of Fortune or something like that, and they have to figure out how much should they charge. Well, what they have to do is figure out what the expected value is of the game. So if we think in terms of money, if this is the game and you spun the wheel, the casino would have to pay out on average $3.52 every time this is played. So what would they charge to play this game? It's a number bigger than this. All right, now they wouldn't charge too much higher than that or nobody would play the game. So even if they charged, say, I don't know, $3.60 or $3.75, or let's just say $3.60, they will on average make 8 cents every single time this game is played. Now you might think 8 cents isn't that much, which it isn't, but if you think how many times a game is played in a day, like a slot machine or something like that, they are constantly pulling that wheel. They're making 8 cents every time that's played. And then how many of those games are in the casino? Well, there's thousands and thousands of games. So yeah, some people will win, but they know on average they're going to make out big. That's why every time I drive by Potawatomi, it seems like that building's getting bigger because they know their expected values. All right, let's do another example. This time, let's make a chart. Pick 2 marbles from 5 blue, 2 red. Without replacement. What's the expected value of picking a blue? All right. So they want an expected value chart, but in order to do that, we need to make a tree diagram first, because I got to get these probabilities. So the first thing you do is actually a tree diagram. We are picking 2. So on the first pick, we can either get blue or red. There's a total of 7, and 5 of them are blue. So 5 sevenths, red would be 2 sevenths. Now we're picking a second time, so we got to branch these off again. Blue, red, blue, red. Now it's without replacement, so we are not putting it back. So we might have to work this problem out, act this problem out. So I put my 5 blues and 2 reds. So I got to act out both scenarios. First scenario is where we get a blue. All right, so if I pick a blue, the chance of picking another blue would be 4 out of 6. And the chance of getting a red would be 2 out of 6. Now down here it's different because on the first pick, we picked a red. So now I got to cover up a red. The chance of getting a blue on the second pick would be 5 out of 6, and the chance of getting a red would be 1 out of 6. Remember, we're trying to find the probabilities before I make this outcome. Now I list all the outcomes: blue, 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 red, red, blue, and red, red. And remember, to find the probability, we multiply. Bottom numbers in all these are going to be 7 times 6, which is 42. Again, we could make them decimals, but I think it's easier to actually do it this way. We should know that 7 times 6 is 42. Now we multiply the top numbers. 5 times 4 is 20. 5 times 2 is 10. 2 times 5 is 10. 2 times 1 is 2. Now I have the probabilities for the outcomes. All right, so now I'm ready to write down the outcome chart. So we have outcomes, probability, product. So if I am picking 2 marbles, now you could do this 2 ways, but really if you pick 2 marbles, what could happen? You could get 0 marbles, 0 blue, 1 blue, or 2 blue. So there are basically 3 outcomes. You could break it up into the 4 and you would get the same answer, but you're doing more work. So it's probably better to do it this way. And it doesn't matter if you start with the big number or the small number. Okay. The probability, again, we're talking about blue. So these are the outcomes for blue. The probability of getting 0 blue would be this number, the 2 reds. 2 out of 42. And if you notice, I didn't reduce these down. It's, again, easier, I think, if you don't. Let's skip this one because that might be a little harder. The probability of 2 blue would be over here, 20 out of 42. Now the probability of 1 blue would be these 2 answers. 10 over 42 and 10 over 42. We have to add those up. 10 and 10 is 20 out of 42. Again, these 3 numbers have to add up to 1, which they do. Now we multiply. That's what product means. We're going to multiply those. And if you remember the nice little shortcut, you can just multiply the big number times the top number. And again, you probably don't even need a calculator for this. 0 times anything is going to be 0. 1 times 20 is 20 over 42. And over here you got 2 times 20, which is 40 over 42. Now if you remember, what we have to do is we have to add all those together. And again, we could use a calculator if we want. Or just add the top numbers. 20 plus 40 is 60 over 42. And we could keep the answer like that. Again, just to give it more reference, more meaning, I'm going to make it a decimal. 60 divided by 42 is approximately 1.43. So the expected value of blue is 1.43. And again, if we call this a casino game, let's say here's the casino game, you play this Wheel of Fortune, you're either going to get bankrupt, $1 or $2. The casino figures out the expected value to be 1.43. So on average, they're going to pay out $1.43 to play this game. So again, what would they charge? A number a little bigger. They wouldn't charge too much more, else nobody would play it. So maybe they charge $1.50. A lot of people will win, but more often than not, they won't. The casino would make 7 cents every time the game is played, and the game is played millions of times on a daily basis. So they bring in a lot of money. Then on Friday, we have our quiz. Here's the quiz. Again, you might have to freeze the video to get it down. And here's the answers to the quiz. All right, that's week 4.